Hello everyone, welcome back to Data Odyssey. In our previous video, we talked about OLAP workload architecture, right? How modern analytics systems basically handle huge amounts of data efficiently. And one of the key components in that architecture is the table format, as we had seen that in our previous video. And that's where Apache Iceberg comes in. But wait, do you remember this concept of table format? That's why I'm just trying to maybe revisit this concept. Okay, so let's quickly revisit this concept and then we'll try to answer a very big question: why Apache Iceberg, which this video is all about. So, a table format is nothing, but it's very similar to an inventory management system of a supermarket. Okay, and in terms of big data workload, you can tell it as the data management system. Okay, it decides how data is stored, how data is organized, how it's submitted inside a data lake. And without a good table format, managing data can become a nightmare. To be true, it can become a nightmare. Okay, slow queries, schema issues, problem with updates and delete, each and everything. Okay, like we had talked about versioning in our previous video. Okay, like this table format is the one which maintains the multiple versions of a particular data. All right, and this versioning actually helps us avoid like issues we can commit in a production level data or any level of data if any wrong transformations are performed and we want the previous version of the data. Okay, and that previous version we can get because of this Apache Iceberg or any table format. Okay, right? So for a long time, Apache Hive was the default table format for big data. Okay, but as data grew, this Hive started showing its limitations, and that's where Apache Iceberg comes in. And today we are answering a very key question: why do we even need Iceberg when Hive tables were already there? Okay, if Hive worked, why change the things? Well, well, it turns out that Hive had quite a few problems that made working with data quite harder than it needed to be. So stick around and I will break down the concept of why Apache Iceberg when Hive was already there into very simple terms with real world examples. Right? So on the screen what you can see, the Hive table partitioning layout, and this is the first thing that we need to understand in order to again understand that why Apache Iceberg came in. Okay, now at the topmost part of this particular diagram we can see dbo.table1. What does it mean? It basically means dbo is the schema of that particular data set where it's being stored, and then within that particular schema we have the table called table1, and this table1 consists of the entire data. All right, now how does Hive work on? Hive works on the concept of on the concept called a directory based architecture. Okay, now what do I mean by a directory based architecture? At the topmost part of the screen, you can see we have dbo.table1. But over you can see we have table1 within the folder dbo. That means what? First of all, we start with the schema, and within the schema folder, we have the table1 folder. And within table1, then we have two parts to it. We have the partition1 folder, and then we have partition2 folder. All right. Now, this within this partition1 folder, we have the data file 1 and data file 2. And within the partition2 folder, we have the data file 1. Now, what do I mean by partition over here? Okay, all of us who know about big data or any data workload, partitioning is known to all of us. But for those who don't know it, partitioning is something on the basis of which we try to divide our bigger chunk of data into multiple smaller chunks. All right, now it can be in various forms. Like partitioning can be done on a particular column which is present in this inside the data, or it can be done on the basis of range. Now when you do partitioning on the basis of range, we call it as bucketing. All right, now understanding about partitioning exclusively and then bucketing, that's a different concept. All right, but these are the two types of manner two ways in which we can do partitioning upon our data set. Okay, now, all of us have understood that this was the particular Hive table partition layout. This was the manner in which data was being distributed when we put data into a particular table in Hive, right? So let's just revisit this thing. So whenever you put data into a particular table in Hive, uh, Hive in Hive format, then what happens that it follows a directory based architecture, and the data files get stored into multiple partitioning folders. All right, and how are the partitioning being formed? It is being formed either on the basis of a particular column which is present inside the data set, or on the basis of a range. Okay, when I mean a column, suppose you have a particular data set which has id, name, and then it's maybe country. All right, so if you tell the table format that you want to exclusively divide this data set into countries, so that means here we have India, and then we have US, then we have Canada. So all the peoples who are there in India will be in a particular folder. Now within India there might be multiple peoples, and if you set the size of a particular data file up to maybe 10 records. Okay, so and if within the country India there are totally 20 records, so within data file 1 there will be 10 records, and within data file 2 there will be again 10 records. And then again we have partition 2. So this one, this it's with respect to India. Then we have partition 2, which is with respect to US, and within that all people who are there in US, up to 10 records will there be in a particular data file, maybe the first data file. All right, so that's how the data is getting divided in a particular Hive table. And if you take the case of bucketing, then maybe on the basis of id you decide that in a particular partition we'll have uh, IDs 1 to 20 within partition 1, IDs 21 to 40 within partition 2. So these are the two ways in which you can divide the data into multiple partitions for a particular table. All right. Now, what was the issue with this particular partitioning layout? And that's these issues are the primary reason why people at Netflix started thinking about a new table format, and that's where Apache Iceberg came in. Okay, now you can see that we are having multiple folders, right? But these multiple folders means multiple files too. Okay, and these multiple files actually gave rise to issues. And how did it give? We need to understand that. But prior to understanding it, let's note it down. So too many folders means too many files. Okay, so all of us have now understood that Hive stored data by creating folders for each partition. It might be on the basis of id, it might be on the basis of name or country, or also on the basis of date. So over time this led to a crazy number of small files, making the things quite slow. Now, what do I mean by small files? Now, suppose you can actually hold 30 records, or maybe not 30 records, maybe this particular entire partition can hold maybe around 50 records. Okay, now within India you have only 20 records. Okay, and what happens that if you have only 20 records, then when you add up all the records of these both of these data file, then there's only 20 records. But partition 1 can handle actually 50 records. That means what? It's a small file, it's not up to the size which can it it's not storing the number of data files which it can store at its optimum level, at its maximum level. That means we are not utilizing the entire partition, and that means it leads to an issue called small files. Now, Apache Iceberg actually tried to resolve this issue using the concept called dynamic partitioning. What is dynamic partitioning? That we will understand in the next video, where we study about the architecture of Apache Iceberg. All right, and that's the first issue. Now there's the second issue again. What is the second issue? Hard to change the table structure. So hard to change the, I'm again telling my handwriting is quite bad because I'm the first time that I'm trying to write on a writing pad and slowly improving, I hope so. Okay. So Apache Iceberg actually struggled with schema evolution. Now why? What was the issue? So in Apache Iceberg, there was a concept actually a physical entity called the Hive metastore. Okay. Now this is Hive metastore. What is a Hive metastore basically? All right. So Hive metastore actually plays a key role in managing schema information. And how does it manage the schema information? Actually, it stores the metadata separately from the actual data files. Okay, so the entire metadata is being stored for a particular table, or all the tables is being stored by the Hive metadata, metastore, and it's a kind of DB actually. All right. Now, since it stores the metadata separately from the actual data files, what happened? It made it like making changes to the schema led to compatibility issues. Now, what do I mean by compatibility issues? Okay, so if you wanted to rename a column, suppose, or change a data type, it could actually break the queries or cause inconsistencies. Okay, and what needed to be done to fix it? We needed to make manual adjustment in order to fix consistencies. Okay, now what do I mean by manual adjustments actually? Okay, so you needed to actually change the metadata in your meta store. So older queries will not work properly after a schema change, because Hive does not maintain the historical versions are all right. So what happened, that suppose you have made changes to a particular column. Okay, maybe see, this column is name over here. All right, now later on you decide that no, I'll not keep it as name, maybe change it to a shorter form, enemy. Okay, called enemy. Now what happened, that the newer versions of data or newer partitions of data will have this particular knowledge that okay, now our table now a particular column name is enemy, but our older partitions of data will not have a knowledge about this particular partition, about this particular column, about this particular older column. And that means we would need to actually make manual adjustments in the metastore to let the older partitions know that no longer this column name exists, it now is an ME. So manual adjustment needed to be made. Okay, and that was a huge issue. And also this led to schema mismatch, right? So queries written before the change expect column to a specific names and the data type, and if those change queries may not recognize the updated structure and could break. What do I mean by that? Basically, if you try to perform query upon that particular table, okay, and there were certain older partitions which had already been written, and you perform query upon that particular table uh, for a data which is present inside the older partition, but with a newer name, then the queries will break, it will not run altogether. But if that particular data is present in the newer partition, then if you query with the new name, then you can get the result. That means there's a schema mismatch issue, right? So that's the problem. And then we again had partition issue, compatibility issues. Why I'm telling this? As we have discussed, right? So if a schema change affects partition columns, older partitions might still follow the old schema, while the new ones will follow the updated schema. All right, so this led to actually inconsistency in the result, and all of these inconsistencies were being there because we were being very dependent upon this Hive metastore. Okay, so the schema in Hive is actually defined in Hive metastore and not directly tied to data files. Any schema updates actually required manual updates to the metastore. All right, and if this wasn't done correctly, queries referencing the old schema will actually fail, because Hive itself is not maintaining the versions of the data itself. Okay, all right, and also because this entire metadata was being maintained by the metastore, updating or deleting data in Hive was slow and complex. So fourth point is messy update and deletes. Okay, So messy updates or deletes. What do I mean by messy updates and deletes? So updating or deleting older data in Hive was slow and complicated. Since Hive was actually originally defined, originally this Hive was introduced for append only workload. All right. And what happened? If we tried to update something, then we needed to rewrite the entire partition itself. So if a particular record is there in this particular data file, okay, that means what needed to be done? You will update that particular record in that particular data file? No. For Hive, what you needed to do, you needed to rewrite this entire partition again, and this made the entire process very slow. The computational costs actually increased, and it altogether was totally a mess. All right. So these were the multiple issues that we had in Apache Hive. Okay. Let us just revisit all the issues that Apache Hive had. So first issue was too many folders means too many files, and it led to the small file issues. Because if we are not utilizing a particular partition up to its optimum level, if a particular partition can hold 50 records and you have only 20 records in that particular partition, then you are not utilizing it at its optimum level. That is, you are not utilizing all the resources, and this led to small file issues. All right. And Apache Iceberg actually tried to resolve it using the dynamic partitioning concept. That means it will decide the partitioning of data not on the basis of a particular partition that we had in the particular data set, but rather itself dynamically based on the number of such that it can actually utilize the partitions at its optimum level. That was the first issue with Apache Hive. Now the second thing was hard to change the table structure. Why it was hard to change the table structure? It was because of this Hive metastore. Each and every metadata information was being stored by the Hive metastore, and whenever you try to make any changes to the table structure, for example you wanted to change the column name, then what happened? The newer partitions, the newer set of data actually reference the new table name, but the older set of partitions actually reference the older table name. Now when you want to query a record on the basis of the newer column name, but it's present, but the particular record is present in the older partition, then there will be a query mismatch or a schema mismatch issue, and the queries will break. Okay, it will not give the correct output, it will give errors. All right. And then suppose if you wanted to update or delete a particular record, then you needed to rewrite the entire partition. So suppose if a particular record is present in this particular data file, that means what needed to be done, you needed to, and you want to update it or delete it, you needed to rewrite the entire partition. And just think of this scenario when you only want to rewrite a particular record, and if you're rewriting the entire partition, that means it's a totally inefficient process. It makes the entire process very slow. All right. So these were the multiple issues that Hive had, and also like entire bottleneck was this Hive metastore. That's we have got to know, because it was storing this metadata differently or at a different place than the actual data files, and that also in a DB format. Okay, and that also used to take a lot of space. All right. So these are the multiple issues that we had. Okay, basically this entire this Hive metastore was bottleneck because schema evolution was totally not supported. It was not it was not error prone. Okay, actually it was error prone, sorry. So it was error prone. This entire schema evolution was entire error prone. So you needed to rewrite the entire table if you wanted to change the column names, so that there is consistency maintained across all the partitions. You needed to transfer the data, then it was totally mess. Okay. And yeah, this Apache Iceberg, what it did was it tried to remove this bottleneck of HMS, that is the Hive metastore. Okay, so as I've told you, like no longer there were too many folders or too many files, a small file issue. It tried to resolve this issue using the uh, dynamic partitioning. No longer there was a Hive metastore. There was no longer any particular DB to store the metadata. There were these metadata were now being stored in files. Uh, this made the entire OLAP workload occupy less space and make the process more efficient. Okay. Now if when we are talking about schema evolution or heart or this table structure change, this it's all the same thing, right? When you are talking about schema evolution or table structure, then Apache Iceberg actually easily supported it. All right, it helped us maintain multiple versions of that particular set of particular data set. Okay, when you maintain multiple versions of this particular data set, then you can query upon the older versions and the newer versions of data according to your wish, according to your requirement. Okay, you need not rewrite the entire partition when you make any update to any record. Okay, so these are the multiple ways in which actually Apache Iceberg tried to resolve it. Like we have understood, we are majorly focusing upon the flaws of Hive, and these are the flaws which actually Apache Iceberg tried to face or tried to maintain, means change. Okay, it tried to resolve these issues which were there within Apache Hive, right? So yeah, that's the thing we I wanted to tell all of you the about. Okay, these were the things related to issues of Apache Hive, the Hive table format basically. And finally, like we will talk about how Apache Iceberg tries to resolve all these multiple issues in the next video, or next to next video. Because in the next video we are going to study about the architecture of Apache Iceberg. All right, and it's very important. This architecture will actually help you understand that how it helped us resolve the issues with Hive table. Okay, so, the final verdict that we need to say or find out is whether Apache Iceberg is better or Apache Hive is better, and like in terms of better table format, Apache Iceberg wins. Okay, but is Hive actually dead? Okay, not exactly. To be true, it's not exactly dead. Some companies still do use it, because Hive has now become a legacy system. All right, so it's being utilized by certain organization which have been using Hive. Okay, but right now all the data systems which are being developed on modern data architecture actually utilize Apache Iceberg as a table format. Okay, because it's also universal, and what I mean by universal, we'll talk about it in the upcoming videos. Okay, so Apache Iceberg is a way to go. It makes your big data basically work more like a regular database without this Hive's headaches. One of the major reasons why this Hive was actually being utilized by multiple organizations previously, it was because Hive actually offered a SQL kind of interface. It was introduced by Facebook, and it offered a SQL kind of interface, because previously you needed to write MapReduce codes which were in Java and very long, and Hive actually gave a SQL kind of interface, and it made the work of analysts and the engineers much more easier. Okay, this was the reason why Hive was actually utilized for many years, and then when Apache Iceberg came in, and it changed the entire scenario. Okay, and it fixes the problems that Hive had and makes the data management way much more easier. Okay, now if I talk about like how Apache Iceberg is being utilized and how basically I utilize it, to be true, in our organization, the client for which we work for, we use Apache Iceberg in a combination with Delta table format. Now that was very new to me when I joined this particular organization and started working for this client, but it was altogether new to me. And then I started exploring this Apache Iceberg as a table format, and the benefits of it was totally, I was totally not only astonished, but I was totally I was very happy. At the same time, multiple kind of emotions went through me, like, okay, I didn't know about this, that this table format is so good. It's so good for big data management. All right, so, folks, if you have been till the end of this video, I'm very thankful to all of you. Please do subscribe to this channel. Please do like this video. Please do share this video. Thank you so much.